This is a tool that's actually going to be very useful to us, both in figuring out where to look for roots and in knowing for sure that we're going to be able to find one. This is a theorem that it turns out is easy to apply, but tricky to understand what it says. This is called Descartes' rule of signs, named for Descartes, the philosopher and mathematician, same guy we get Cartesian coordinates from. The I think therefore I am guy, that Descartes. Descartes' rule of signs says, if we have a polynomial with real coefficients, so the coefficients have to be real numbers. They don't have to be integers, just real numbers. And it's written in descending order, so x to the third, x squared, x, and then the constant. The number of positive real roots is either equal to the number of sign changes, what's a sign change, of the coefficients, or less than that by an even number. This bit is a little bit unfortunate. It makes this a little bit less useful than it would otherwise be. So that tells us about the positive roots. To figure out the number of negative roots, we apply the same rule to what we get when we plug in negative x to our polynomial. Okay, with that statement, we kind of have no idea what it's talking about. We also can't really prove it because we don't have the techniques available to us. So the most important question we probably have is, okay, what's a sign change? To see, let's look at an example. It's easy to see in an example. In this polynomial, we have the coefficients 1, 3, -10, and -24, in that order. So our first two coefficients, 1 and 3, those are both positive. But then 3 is positive, but -10 is negative. That's a sign change. We go from being positive to being negative. Our coefficient goes from a positive number to a negative number. That's a sign change. But then -10 and -24, those are both negative. That's not a sign change. This polynomial has one sign change, so according to the rule it must have one positive real root. Exactly one, right? Because less than that by an even number, 1 minus 2 is -1. It doesn't make sense to have a negative number of real roots. We have to have exactly one positive real root. That's great. We know there's something there. What about the negative real roots? For that we have to find out what p of -x is. So remember that if we have an even power of something negative, that's the same as the even power of the positive version. If we have an odd power of something negative, that's the opposite of the odd power of the positive version. So if we have -x to the third plus 3 -x squared minus 10 -x minus 24, well, we'll have a negative x to the third plus -x squared is the same as x squared, so this is just plus 3x squared. Minus 10 times -x is the same as positive 10 times x, and -24, nothing happens. So the thing to note is, when we do this, we reverse the signs on terms with odd powers of x. So that's going to give us a convenient shortcut that we're going to use a lot. So in P of negative x, coefficients are -1, 3, 10, and -24. Our first coefficient is negative, but then 3 is positive. That's a sign change. 3 is positive, and 10 is still positive, not a sign change. 10 is positive, but then -24 is negative. That's a sign change. So we have 1, 2 sign changes. So this polynomial might have 2 negative real roots, or it might have 2 less than that. It might have none. It either has 2 or it has none. In fact, for this polynomial, the roots are -4, -2, and 3. So we have 1 positive and 2 negative. One nice thing about knowing that it either has 2 or 0 is that if we find 1 negative root, we know that there's another one. So that's nice. Okay. The biggest thing that this does for us is when we're going about our trial and error, it gives us an idea of what to try first. For example, in this problem, if we wanted to try to factor this, I know for sure that we have 1 positive real root, so I'm going to try some positive numbers first, because I know I'm going to find something there. It might turn out not to be rational, but I know that there's some positive number. In the next video, we're going to see a way that we can know that we can stop trying things, that we can eliminate some of the possibilities. This tells us where we are likely to find things. The next thing we're going to see is knowing where we should not look.